Hey DSA coders, I hope you people are doing good. Let's dive into deeper another new problem, which is nothing but the lead code number 2749, which is the minimum operations to make integer zero. You have to do some minimum number of operations so that the integer that they have given will comes into zero. What are all those operations? Come, let's dive into the question and solve. Let's say you are given two integers num1 and num2. Okay. In one operation, you can choose integer I in the range 0 to 60 if this is written in square brackets, which is nothing but inclusive of 0 and 60 as well, and subtract 2 power I plus num2 from num1. Okay, what they are saying is something like, let's say I have some number as num1. I need to subtract it with 2 power I plus num2 in order to get the result 0. So this can be something like an iterative steps, like you can iterate from I varies from 0 to 60. Okay, so this is what they are mentioned. Return the integer denoting the minimum number of operations need to make num1 equal to 0. If it is not possible, then return -1. Okay, so as per the question, what we can state is like something like there will be something called num1 and you have to do an operation nothing but subtracting num1 with this 2 power I plus num2. Okay, so in order to get the value 0, so which is like a recursive kind of step. Okay, so if you find something like you need to subtract or you need to add, you need to do this, do that, like some kind of mathematics, all those stuffs. If you find something like that, definitely get the value 0. So which is like a recursive kind of step. Okay, let's dive into deeper and let's understand we just understand what is what actually. So if you find something like what do I mean is like you need to subtract or you need to add, you need to do this, do that, like some kind of mathematics, all those stuffs. If you find something like that, definitely all the solution arises between something like you need to frame an equation. Okay, so this is what requires. Whenever you see something like as add, subtract, multiply, or do some manipulations in the number, all those kind of things, you need to form an equation, which is nothing but an algebraic expression or something like that. Let's say I'm going to do k number of times. Assumption. This is also assumption. I know that in k number of times, I can make the num1 to 0. Okay. Okay. So what does this refers is? Let's say k can be varies from 0 to 60 anywhere actually. So right. So what do I mean is like I'm going to iterate through all the elements k times. K can be like from 0 to 60. So I'm going to write a general expression. Num1 will be equals to num1 minus k times of 2 power I plus num2. According to this equation, as you see, under this equation, you can see something like num1 will be variable. Varying in the sense, in the initial step itself, you won't get num1 as 0. This equation to final num, which is equals to num1 minus k times of 2 power I minus k times of num2. I can write it in this way. Now k times of 2 power I, which is nothing but sum of powers of 2. Okay. What does it means like? Let's say 2 power I can be like 2 power I, 2 power I, 2 power I, like I varies from 0 to something. That is I'm going to do like k times. So I can write something like sums of powers of 2, which is as simple as that. So, and also we know that at the last step, this final num will be changes to 0. So I can write like this 0 equals to num1 minus k times of nums2, then minus sum of powers of 2, right? As simple as that. Yes. Now, just reframe this equation. Reframe in the sense, let me bring the sum of power of 2 to this side. which can be write something like sum of powers of 2, which is equals to num1 minus k times of num2. Okay, so now what I'm going to do is like based on this equation, I'm going to figure a formula and I'm going to frame an equation right now. So what I'm going to do is like, let's say num1. Let us dive with the example itself. Here they have given num1 as 3 and num2 as minus 2. So let's see num1 as 3, num2 as minus 2. Okay. So what I can do is like, let's solve this. Num1 will be 3 minus, let's say initially k is equals to 0. So 0 times of minus, let me bring the sum of power of 2 to this side, which can be write something like sum of powers of 2, which is equals to num1 minus k times of num2. Okay, so now what I'm going to do is like based on this equation, I'm going to figure a formula and I'm going to frame an equation right now. So what I'm going to do is like, let's say num1. Let us dive with the example itself. Here they have given num1 as 3 and num2 as minus 2. So let's see num1 as 3, num2 as minus 2. Okay, so what I can do is like, let's solve this. Num1 will be 3 minus, let's say initially k is equals to 0. So 0 times of minus 2, x equals to this. Now, what I'm going to do is like, I'm just checking whether minus 2, 11, right? Now, we knew one thing like this 5, which is nothing but we need to express it with sums of powers of 2 in order to find the solution. Because that is what the statement is, because we have done this. That is nothing but 5, 7, 11, all those stuffs. Now we need to equate it so that we will get a value like sum of powers of 2. Okay. How do we do that? As we already knew that sums of powers of 2 it is like 5, I can write it in the binary values, which is nothing but 0, 1, 0, 1, right? For 7, 0, 1, 1. For 11, 1, 0, 1, 1. Which are all basically 2 power 0, 2 power 1, 2 square, and 2 cube, right? Sums of powers. So what we can do, we can just check whether this numbers are less than or equals to k. Let's see if integer dot bit count of x, which is lesser than or equals to k, then return k. That's it. So what does this infer is like? Let's say your k value is something like, here the k value is 1, here the k value is 2. Now the k value is 0, 0, okay. Bit count for this is like 2, right? So 2 is less than or equals to 0. It's false. Okay. Now again it just goes 1. For 1 it's 7. 7 it's 3. Bit count is 3. 3 is less than or equals to 1. False. Again it goes. Again it comes something like 3. 3 is less than or equals to k. K, what's the k now? It's 3. So 3 is less than or equals to 3. True. So whenever this bit count of x and the k value comes less than or equals to, yeah, this is the answer. So whenever this condition occurs on the very first time, this will be the answer. So that I'm returning it. If you are not finding something like that, just simply return -1 here as well. That's as simple as that. So I'm just going to write me code in Java so that it will be like quite understandable and easy for you as well. Okay. Let me frame something like k equals to 0. Okay. And what I'm going to do is while of true, because we doesn't know that at which place it's going to do. Okay. While of true, x equals to num1 minus k into num2 if x is less than k. This is what the first condition that I mean, right? If x is less than k, just directly return -1 because this is the base case. If integer dot bit count of x which is less than or equals to k, then return k. Okay, since if this fails, this also fails, just directly increment the k so that k moves to the next loop. Okay. To make the code to work properly, I'm going to write something like return -1. Of course, this doesn't comes to any. In somehow, if something like somehow, the results will be coming from either this or either from this. It is at worst case, it will be like reaching over here. That's it. So that's all the code, which is very simple. I hope you people understand. I will see you tomorrow with the next new problem. Goodbye and signing off. Bye.